Hi guys, and welcome to another video on calculus. In today's video we're going to look at differentiation. Now in the last video we looked at finding the derivative using first principles, or it's the same thing as saying differentiating using first principles, but in today's video we're going to look at a method that is a little easier. Okay, let me be truthful, a lot easier than doing first principles. So we're going to use what is called the power rule. So if we have a function in the form ax to the n, then the derivative is equal to n times ax to the n minus 1. So what this is saying is we multiply by the power and we subtract 1 to get it from the power to get the new power. So we bring down the power, multiply, and then we subtract 1. So let's look at an example. So in the previous video we found the derivative of 3x squared plus 4x using the first principles. Now we're going to use a power rule. So according to the power rule, we bring down the power, so we multiply by the power. So we have, this is the power here, we bring that down, so we have 2 times 3x to the, and then we subtract 1 from the power, so to the 2 minus 1. Now similarly for 4x we have, so we put back our plus 4x. Now remember from algebra this is just 4x to the 1, so we'd bring down the power, so it'd be 1 times 4, so that's still 4, to the 1 minus 1, and that gives us 6x to the 1 plus 4x to the 0. Now if you recall, anything raised to the power of 0 is just 1, so this is just 6x plus 4 times 1, which is just 6x plus 4. And let's look at another example. So we want to find the derivative of the square root of x plus 3 divided by x. Now before we're able to apply the power rule, what we need to do is we need to rewrite this in such a manner that we have our x being raised to a power. So for the square root of x, we don't see it being raised to a power, but we're able to do so. The square root of x is the same as x to the half, and 3 divided by x is the same as saying 3 times x to the negative 1. So this is just using some of your old algebra knowledge. So now we're able to apply the power rule. And once again, applying the power rule gives us a half x to the half minus 1. So here this should be a minus, so we have a minus 1 here, so we should take down that, so this should be a minus. Alright, so we have a half x to the half minus 1 minus 3x to the minus 1 minus 2. So this would give us this here, except that we need this to be a minus. Now let's look at example 3. So we have f of x is equal to 1 divided by x to the 5th power plus 4 divided by root x plus 7. Now once again we need to have x being raised to some power, so we need to have x to whatever that power is, so we need to rewrite these. So these are the same as x to the negative 5, 4x to the negative half. Remember, square root of x is just x to the half. The fact that we bring it up becomes to the negative half plus 7. So applying the power rule, we have, so multiplying by negative 5, we have negative 5x minus 5, we subtract 1 from the power, so minus 5 minus 1, multiply by the power, so we bring down that, we have negative a half times 4x to the negative half minus 1 plus 0. Now whenever we differentiate a constant, it's always 0. It doesn't matter how big or how small that constant is. Whenever we differentiate a constant, remember a constant is just a number without a variable. Once we differentiate a constant, the result is always 0. So pretty much we are finished differentiating this. We just need to tidy it up a bit. Alright, so we have minus 5 x to the negative 6 minus 2x, so negative a half times 4, negative 2, so minus 2x to the negative 3 halves, negative half minus 1, negative 3 halves. And we can go a bit further, flex our algebraic knowledge, and we can write this as negative 5 divided by x to the 6. Remember, so we tuck this under the 5, so this sign here now changes. This negative now becomes a positive 6 minus, and similarly we tuck this under, so this power will become positive. It's going to be raised to the cube, and the half is where the square root comes into play. So this, we aren't really focusing on this part. This is more algebra of it, which hopefully you're exposed to. Alright, so that's our video. That completes our video. Here we have 3 lovely examples of how we can differentiate using the power rule.